Alright, welcome back everybody. In this video we're going to look at the last couple of examples from the definite integral and area lesson. We'll start here with example 5. We've got a given graph and we've got two different things to do. The first thing we're going to do in part A is we're going to find the area between the curve and the x-axis from -3 to 7, which is going to count all of this area between the curve and the axis as positive area. And then the second part we're going to find the integral. And when we do that, anything that's below the x-axis is going to be considered as negative area. So we start by first finding all of these areas and counting them as positive in order to find the value for part A. And we start with this triangle on the end, which has a base of 3/4, which you can tell from the slope of the line segment, has a base of 3/4 and a height of 3. And so that's going to be the first area of the region. And we're going to count it as positive because we're finding the area between the curve and the axis. Then the next triangle that we have has a base of 2 1/4 or 9/4 and a height of 1. And so we've taken care of this area and this area so far. Then we have a semicircle with a radius of 1. So that's going to be half of pi r squared. And then we have a quarter of a circle with a radius of 2. A quarter of a circle with a radius of 2. And then we have a triangle, a base of 1 and a height of 2. And then we have this last region, which is, the leftover from a quarter circle. So we've got this square, and we're taking away the area that's in green. So the area of that is going to be the area of the square, which is 4, minus the area of the quarter circle, which is a quarter times pi r squared. And we're going to add all of these values together, and that's going to give us the area between the curve and the axis. Alright, so let's see, we've got 9/8 plus another 9/8 plus pi over 2 plus pi plus 1 plus 4 minus pi. And if we add all of those things together, let's see. The things not containing pi's, we've got 9/8 plus 9/8, that's 9/4, plus 4/4 is 13/4, plus 16/4 is 29/4. And if we add all the pi's together, we've got pi over 2. And so there is the area between the axis and the curve. Now when we find the integral, we're going to do the same thing, except we're going to count all of the regions that are below the axis, this region, and this region, and this region, as negative value. So we've got a -9/8. The next region is above the axis. The next region is above the axis. The next region is below the axis, so we'll count that pi here as negative. And the 1 is also below the axis, so we'll count that as negative. And so going ahead and doing these calculations, we end up with the value of the integral being 3 minus 3 pi over 2. And the value of the integral there is actually a negative value because there's a little bit more area below the axis than there is above the axis. So this example should have illustrated to you a little bit more of the difference between calculating the value of the integral and calculating the area between the curve and the axis. Alright, let's look at the last example here, example 6. Using the fact that the integral from 0 to pi of sine of x dx equals 2, we're going to find the following integrals. Okay, so think about what happens with the sine function. Sine is 0 at 0 and goes, looks like this. And what we're told in the given is that this right here, the value of that area is 2. Alright, so that means that the area under any arch is 2, and if that arch is below the axis, the integral is going to count it as negative value. So let's go ahead and find these values. The integral from pi to 2 pi of sine of x. All that is it's the area of this second arch, the one that is entirely under the axis, and so the value of that is going to be negative 2. The integral from 0 to 2 pi of sine of x dx. Now we go through and we look at these first two arches. The integral counts the first one as positive 2, counts the second one as negative 2, and so adding those together, the value of that integral is just going to be 0. For 0 to pi over 2, well, now we're taking just the first half of this arch, and so it's going to be half of the total area, so the value of that is going to be 1. Relatively easy to do when we know the area under one arch of these curves. Alright, next. The integral from 0 to pi of 2 plus sine of x dx. So consider what this curve looks like. All it does is it takes the entire sine curve and bumps it up 2 units. And so finding the integral from 0 to pi underneath that curve, we've got this region up here, which we know has an area of 2, and we've got this rectangle, which is 2 units tall and pi units wide. And so the total area above the axis is the area of the shaded region, plus the rectangle, which is 2 units tall and pi units wide, and a rectangle. You just multiply length times width. And so that is the value of that integral. Excuse me. Alright, next we have the integral from 0 to pi of 2 sine of x. Well, this is the same curve, except at every single point, the y-coordinate is twice as high. And so the area is going to be twice as much. That's going to be 4 units. Next, let's see, the integral from 2 to pi over 2 of sine of the quantity x minus 2. Well, this is just equal to, because all this is doing is performing a horizontal shift, this is equal to the integral from 0 to pi of sine of u du. And so that's just equal to the same as the integral from 0 to pi of sine of x dx. So that value is going to be 2. Integral from negative pi to pi, we've got a negative arc and a positive arc. Those cancel each other out, and so the total value of that integral is going to be 0. And from 0 to 2 pi of sine of x over 2, okay, so that is just taking this and spreading it out. Again, kind of like I did in part F, I could rewrite this as the integral from 0 to pi of sine of u du, since if I just make the replacement that u is equal to x over 2, and so that's going to have a value of 2. And the last one, the integral from 0 to pi of cosine of x. Now let's see, cosine looks like this, from 0 to pi over 2, or from 0 to pi. And so we have the same amount of area above as we do below. Those will cancel each other out, and so the value of that integral is going to be 0. It's a cute little example, and just illustrates some of the things that we can do when we know the value of a particular area and the integral related to it, how we can find some other values. Alright, that's the end of this video and the end of this lesson. See you guys next time. Have a great rest of your day.